Good morning or good afternoon, depending on where you're joining us from, and welcome to today's webinar. I'm Cess, your host from Business Review, and it's truly a pleasure to have you all here. We're delighted to have our wonderful sponsor, E1, with us today, who'll be presenting this webinar titled Hydrogen Cooled Generators, Best Practices for Safety, Efficiency, and Risk Mitigation for 2024 and Beyond. Let me introduce our esteemed guest speakers for today. Our first speaker, Christopher Breslin, Technical Advisor from E1. Christopher has worked with E1 for more than 18 years and has been involved with manufacturing, engineering and management, sales, pre-post sales support, and contract management. And our second speaker, Mark Williams, Business Development Manager from Environment One, E1. Mark has more than 15 years of experience in E1 sales and over 32 years of field service customer support experience. Mark has worked closely with power plants around the world in areas of maximizing safety and risk mitigation. Now, before we begin and dive into the content, let me take a moment to familiarize you with our webinar platform on 24. The webinar is browser-based, so if you happen to disconnect for any reason, simply click on the link that you received via email to rejoin the session. Additionally, today's webinar will be recorded and available on demand access. Should you have any questions or thoughts during the presentation, feel free to use the questions widget. Just type them into the box located at the top right-hand corner of your screen and click submit. We'll set some time at the end of the session to address your queries. For any technical assistance, the yellow help widget is at your service, and you can adjust or maximize any of the windows on your screen for a better view of the slides. Now, without further ado, let's extend a warm welcome to our first guest speaker, Christopher.
Good day, everyone. I will be speaking first today, and I will be speaking on contamination, degradation, and safety concerns in your hydrogen-cooled generators. Today's basic program outline, we'll spend a little bit of time on hydrogen review, why we use hydrogen generators. It'll be short, but we just want to make sure that we're spending a little bit of time on that. We're also going to discuss improving the accuracy of your hydrogen purity reading, some time on reducing contamination and windage in your generator, some incremental asset protection that you may be looking at as your generator is aging, and then we'll be moving on to Mark speaking on safe purging, potentially automation of that purge via an operator-initiated purge function. First, how many of you currently are using hydrogen as a cooling gas in your generator? And you can just click on your screen whether you do or do not use it, please. So a hydrogen-cooled generator or another form of cooling. Okay, hoping everyone has locked in their answer here. Give you another second or two. Excellent. We'll be moving on now. So 78.8% of you are using hydrogen as a cooling gas, and 21% are not using hydrogen as a cooling gas. So a lot of this is focused on hydrogen-cooled generators, but for those of you that are not using hydrogen, we have some opportunities and can discuss things in the future as well. So again, just making sure we go through hydrogen review. Hydrogen, why do we use it? It's the lightest element. Molecular weight is 14 times lower than that of air, 14 times better specific heat than air, and 4 times less relative density which will result in lower windage and better heat rate versus an air-cooled generator. Hydrogen-cooled generators of the same rating as an air-cooled generator can use approximately 20% less copper in their windings and less core iron as well. Because hydrogen-cooled generators must be very well sealed to safely contain the hydrogen, the environment is controlled. So the generator stays clean, and it's easier to control moisture in a hydrogen-cooled generator. Hydrogen is not an oxidizing agent, and the generator pressure in a hydrogen-cooled generator suppresses partial discharge and increases the level of voltage that's required to break down components. Stated simply, that sealed environment helps minimize mechanical, electrical, and corrosion problems. Hydrogen is extremely available and can even be made on site. Developments will keep advancing as plants are preparing to run on blends of hydrogen fuel in different areas. And last but not least, hydrogen burns with a bluish, almost invisible flame. So yeah, that's right. There's a downside to hydrogen. On the previous slide, almost everything seemed like a plus, but then we run into some potential safety concerns. But those safety concerns can be mitigated. We've been working around them for a long time with mixed levels of success in our industry. I could show many photos of devastation, and we've seen them in a variety of presentations in the past to both humans and industry assets when we don't follow proper safety practices regarding hydrogen. But these days, you all know how to use Google or your browser of choice, and you'll find plenty out on the internet, whether related to purging error, hydrogen delivery error, seal failures, or some other form of hydrogen defect. We all know the standard fire triangle, which we typically address in our industry by trying to remove the ignition source, as well as keeping the air and the fuel, in this case hydrogen, separated from each other. Almost more critically than that fire triangle is the hydrogen safety triangle. Having the correct equipment that you can trust, properly documented processes, and ensuring we have the right people properly trained to manage the risks. Some basic hydrogen hazardous areas best practices. Hazardous areas require precaution. One of the main things to lead to that precaution is appropriate operator training. It's the most critical element of safe plant operation. Making sure right people trained properly to mitigate the risk inside of your plant. Adequate signage, identifying where those hazardous areas can be and what precautions need to be followed. And that signage can be very simple, saying, hey, this is the area where I could have this hazardous area, hydrogen is there. But we've also seen some very simple signs lead to some positive results. Perhaps a simple sign that tells what gas is in your specific generator when you're going through the purge process. Is it hydrogen? Is it CO2 at this time? Is it air at this time? So that when an operator walks up and is going to move on to the next gas, they know exactly what they're dealing with inside of that generator and no errors are made. Another area there is the use of qualified EX certified maintenance personnel for equipment in hazardous areas. And in some countries, this is in fact required. If you're going to be working on equipment in a hazardous area, you might have to have CompEx trained employees or technicians. Some best practices. Obviously, regular calibration of your hydrogen purity meters. Most every hydrogen purity manufacturer out there on the market today is going to have a calibration listed in their manual of 3 months, 6 months, etc. Environment One puts in our manual 6 months. We know that you can run them to a year, but we often recommend that 6-month calibration just to make sure that you always have an accurate reading hydrogen purity meter. You also obviously want to strictly adhere to your generator purge procedures, making sure that the procedure that you have is for the generator that you're working on right now. Compare it to your P&ID. Make sure the valves that you're about to manipulate line up with that procedure. Many times in a plant today, while this plant may be 30, 40, 50 years old, improvements have been made over time. And maybe those improvements didn't make it to all of the generators that are in line with each other. So they're similar, but no longer identical. And you want to make sure that the procedure that you're utilizing is for the generator that you're working on at the time. And again, back to calibration, if you're moving into a purge process on your generator, you should be calibrating your hydrogen purity meters right before you do that purge to make sure you have the utmost of accuracy and safety in that process. You only want to use spark-free tools in the hazardous area specifically. So if you may have that hazardous area existing, you want to make sure you're using the appropriate tools for it. And of course, you always want to adhere to all of your OEM prescribed maintenance on all of your equipment operating in a hazardous area. There's some industry dynamics that are going on in the industry for sure. The generator fleet as a whole is getting older. Sure, we're still putting new generators out there, but we're also extending the life of many generators that are already existing in the field. And with that fleet getting older, the hydrogen auxiliary equipment is also getting older along with it. Our workforces are in many cases getting younger and leaner. When I first started in this industry, we were talking about people going ahead and getting older and working towards the retirement. And then we found people that were newer in their career that needed to learn and grow through. And then we've watched those people now work through and gain that experience. And some of those people are now retiring, and it continues to ebb and flow in different areas. We're also finding that training programs are less frequent than they used to be. And the time between outages are getting longer. And it may or may not be true in your area, but renewables may be changing the generation profile for sure in certain areas with generators. And all of these factors increase the importance of a well-managed hydrogen auxiliary maintenance program. So why do we monitor hydrogen purity? The prime of your hydrogen purity is safety. The flammability range is from 4 to 75% hydrogen in air, which I stated earlier. There are explosive limits between 17 and 56% hydrogen in air. These are definitely reasons that we want to make sure that we're protecting our people and our plant assets. The other significant reason for monitoring hydrogen purity is efficiency. And again, that monitoring, it's happening all the time. It is one of the key auxiliaries that comes on every generator that's cooled by hydrogen. It's performed during the gassing, during the degassing, and in all phases of normal operation of the generator. So we're always monitoring hydrogen purity, and this should be happening as a standard auxiliary on every hydrogen-cooled generator in the world. Get the slide. Guys, my slides are not moving the way I expected. Give me a second. Has 5 different slides on it here. The methods that are commonly used are a manometer, gas density, vibrating element, and thermal conductivity. Some hydrogen purity monitoring considerations that you're working with here are accuracy and stability or drift, the measurement ranges and redundancy. So perhaps now you're interested in seeing, as we're moving to more DCS-based systems, we're looking for redundancy sometimes. You may want to see everything coming into you in two separate ways so that you can make easier decisions. We're also concerned about your sampling location and whether you're using filtering or flows. Is there desiccant inside of your system? Do you have a scavenging or a vacuum seal oil system? And then again, the hazardous area and the location may matter. How is this area classified? Different countries have different requirements. Here in the US, it happens to be class 1, zone 2, group 2B plus hydrogen, or 2C. This chart is a typical chart that you would see in almost any generator manual. This happens to be a Westinghouse generator. And what it basically shows is that as purity increases, your windage loss decreases significantly. There's also a correlation with generator pressure, as you can see in the 3 different lines on the chart. There can be a windage loss increase or decrease based on the gas pressure and the hydrogen purity inside of your generator. That windage loss can be converted into a financial loss based on the wholesale electricity pricing in your area. So this is another way to look at that. It's basically a slide, this time turned around, shows that as our hydrogen purity decreases, moving to the right, our windage loss will increase on the scale, the up and down scale. This shows 2 separate units, a 400 megawatt unit and an 800 megawatt unit. That purity has a tremendous effect on the density of the gas inside of the generator, because generally anything inside of the generator that is not hydrogen is air at 14 times greater density than what the hydrogen was, which we were showing earlier. Even worse is if that alternate gas happens to be CO2. So therefore, again, as the purity decreases, the windage loss increases drastically. Inside of this chart, you can basically see that on the larger unit, a 2% increase in your purity, which could just be in the accuracy of your hydrogen analyzer, could actually show you a savings of $1,272 a day or $464,000 per year. That makes an upgrade to your hydrogen auxiliaries, especially around the purity side, bring back a return on investment very, very quickly. So sometimes not updating these systems has a negative detrimental effect on your overall system. Next, we've got a poll for you. So if you could please go ahead and answer the poll question, that would be greatly appreciated. Okay, now you should be looking at a screen that shows hydrogen purity monitoring. Why upgrade? So your existing equipment does not operate properly. Potentially, it's not trustworthy. That's really the big thing, is do you trust that equipment that you're utilizing right now? You might also be working against obsolescence. As we mentioned, this equipment is getting significantly older. So perhaps you want new functionality as required or desired. As Mark's going to be discussing, maybe you want to move to automating your purge. And so in the process of updating your auxiliaries, you're going to incorporate in new functionality where you get automation, Perhaps you add in a generator condition monitor, PD, etc. So you want to add additional functionality. And perhaps the existing equipment doesn't meet the current EX standards for your area. When these plants were built a long time ago, we may not have understood quite the same things. The images I showed earlier of different purity systems, one of those was an explosion-proof purity analyzer plugged into a regular outlet. That's really not up to the standards of what we're looking for today. So in the process, you can move to the latest and greatest of safety standards. And then obviously risk mitigation. We've already discussed the safety side of it. So that risk mitigation is going to be one of our significant things. So then we're going to move on from purity to why we would monitor dew point, why we want to maintain dry hydrogen. In this case, the primary reason is component and insulation failure. This could support insulation failure via electrical tracking. With the moisture, there could be significant corrosion effects inside of your generator. So the retaining rings is one of the main areas that people are looking at. It's the most highly stressed mechanical component, as it's basically shrink fitted over your rotor, and everything is trying to push that out as your rotor is spinning it at operating speed. One of the other things that can happen is cyclic generator operation can actually create an issue there as well. And then the secondary reason that we're looking at it is efficiency. So if we can get better dew point, less moisture, we can also increase our efficiency. This slide shows that purity has actually a far greater effect on the density or windage inside of your generator, but the moisture still actually has an effect. So that top line is your mixture density as a function of air, and then the lower line is your function of dew point. So as you can see, the efficiency change isn't as big of an improvement as you have with the hydrogen. But if your generator is wet enough, you're beyond the 0 degrees C point, you can actually see some improvements. All of the OEMs recommend that you maintain your dew point below 0 degrees C. So where does this moisture come from? The primary source is often your seal oil and your seals. This can also come from your hydrogen coolers. You can also see it if there's a leak in your cooler. Stator cooling water can have clip leaks. And then again, the actual thermal cycling of your generator. When you're operating, you're warm. When you come down and things are cooling off, sometimes you get condensation leading to moisture inside of your generator. So by maintaining and controlling that dew point, you can reduce that effect. And again, here's the things that we're trying to reduce and not see by drying our hydrogen. On the left-hand side is a retaining ring failure. On the right-hand side is a shorted turn. If you want some more information on the effects of moisture and shorted turns, there's a great paper that you can go find online by Dave Albright of Generator Tech. So you can use that Google search function and go check that out. So now we're going to move on to some incremental asset protection. Condition monitoring devices are important tools in risk mitigation. As the risk factors in the fleet increase, additional monitoring becomes necessary. On the lower left-hand side here, you see the traditional OEM standard auxiliary equipment that came with your generator when it was new. As your risks increase, you may decide that you now need to add additional incremental asset protection. What types of factors are those? As we already said, a lot of times it's age. What's the size of your generator? How critical is this generator to the fleet? What's your operator experience? Do we have those newer in career people without the experience? Maybe we need to have more tools available to make the appropriate decisions in how to operate our assets. And then our plant staffing level can be a factor as well. Those original OEM supplied equipment things, as we discussed earlier, hydrogen purity, one of the main items that's there, that's going to be there always for safety. It also can help you find faulty seals if you happen to have a scavenging seal oil system. Vibration monitoring can be there, looking for rotor vibrations, standard overload protection, looking for overcurrent, and then temperature sensors. Those temperature sensors could be RTDs, thermocouples, and they're looking for overheat, heat exchanger failure, and insulation failure. Moving forward, you might be looking to add these types of additional condition monitors as you move forward now as the risk increases. Maybe you're looking at fiber optic accelerometers for end turn vibration, partial discharge, which can help you find your stator insulation breakdown, flux probes, looking for shorted rotor turns, radio frequency, which can help you look for arcing, dew point monitors, looking for moisture, or a generator condition monitor, helping you look for insulation degradation, arcing, etc., inside of your generator. This can be looked at through this Venn diagram as another way to look at that. This is basically all of those technologies put onto one page. And what it really shows is that it's not an exact science with these auxiliaries. Many times there are a lot of tools, and you look at the signals that you're getting from a variety of those to help you make a decision at some of these overlap areas. These technologies are all complementary to each other. So you may want to have all of them as you're moving forward and improving your reliability. So I want to know, is my insulation degrading? How do I do that? Well, you might be doing that with a generator condition monitor. The generator condition monitor looks for overheat, degradation of insulation. It's all thermal decomposition of materials inside of your generator. That could be your epoxy paint, your core lamination. It could be something as simple as you dumped a little bit of oil into your generator and now that's overheating. As that overheats, all of those things would give off submicron particles as they degrade. And that is sensed by the generator condition monitor. The generator condition monitor, GCMX specifically, is designed for use on all generators that are cooled by hydrogen. There is another technology called the GCMA that can be used in air-cooled generators. What are we specifically looking for? I mentioned a lot of times we're finding that oil, but what we're looking for is this stator winding failure on the left-hand side, or this core burning on the right-hand side. The GCMX can sense things very quickly. It can be as small as a 2-inch by 2-inch square inside of your generator that can be detected. The principle behind it is ionization. That gas can transmit a current when a voltage is applied. The submicron particles from that degradation will impede the flow of current. So when clean hydrogen is flowing through the GCMX, positively charged ions are attached to a negatively charged electrode and gives an output that we just correlate to 80%. Those submicron particles, if you have an overheat happening inside of your generator, they will flow, they will grab onto those positively charged electrons, and they will actually slide past the electrode, and the output of the ion chamber will drop drastically. The output is related to that very subtle change in current. And when I say subtle, all of this current we're discussing is measured in picoamps. So it's a very, very small output that we're amplifying here. And you do need to have consistent hydrogen flow. That's an important factor. If you happen to already have a generator condition monitor, you notice that we put out alarms for flow because the flow will definitely impact the output. This thermal particulation is not subtle. Millions of these submicron particles will come off whenever this degradation occurs. So therefore, it creates a dramatic signal, dropping that 80% output very close to zero. It's facilitated in this hydrogen-cooled, pressurized generator environment because it's sealed. It's very easy to detect. It's only coming from this thermal degradation. There's minimal interference, partially because it's minimal mass. These submicron particles provide very, very early warning in the process. And with that, I'm going to turn this over to Mark Williams, who's going to jump into some great implementation things on best practices for safety, efficiency, and risk mitigation as he talks to you about remote operator initiated purge.
All right, thank you everyone for joining us, and thank you, Christopher, for the great information on maintaining and protecting your generator assets. We're going to pop into automated purge systems, how we can do it, and what we need to know. First thing we're going to look at, we're going to define a remote operator initiated purge system. What are the benefits of an automated purge system? What we need to know to get started. These are some very important points that we need to keep a close eye on as we build a system. The options for automating your purge system: connection points to your generator and manifold, CO2 vaporizer options, and a 7F automation kit that was put together to adapt to any 7F around the world. So what is a remote operator initiated purge? It's a system that can be initiated directly in the control room by an operator when he sees a situation where we need to protect our assets or our people, that is embedded in your DCS software, be it Ovation, Mark 6E, Mark 5E, Mark 4E. We like to keep it in your system so that you have control. If changes need to be made, this can easily be done. This is an example of a purge scene screen that an operator would see inside of the control room. We have our hydrogen analyzer statuses, last read values, valve status values for open and close of the three main valves that we'll be looking at, seal oil pressures, generator gas pressure, and the differential pressure to make sure that we don't blow the seals out in the process of a purge, along with your typical screens that you would see for monitoring other areas of the generator. These will be added to this main screen for you. So when we look at an ROI purge system, we're looking at a complete system that encompasses your generator, your hydrogen purity monitoring, your screens in the control room, a remote automated purge rack if you have a good manifold to integrate and activate the purge over your manual functions, and of course, a vaporizer. We prefer ambient vaporizers. They do not need any 480 or 460 to run, and we can gain great efficiencies by using them in your purge process. What are the benefits? It's the same process every time, no matter who is doing it. We have, as Christopher spoke of before, we have had a big changeover in at least two since I've been working with Environment One of operators and plant personnel. So we've gone from very experienced operators to a lot of newer people that don't get to see a lot of purges. So this is a big benefit to keep it safe and being done the same way every time. If there's an emergency, there's no need to go in harm's way. No one needs to go out where there's a fire on a generator to get that thing purged. Or if we have a weather incident, we're looking at hurricanes coming in, tornadoes, any act of God that could be detrimental to the plant, nobody needs to go out there. It will speed up the time a purge takes with the correct equipment and process. And this is a very important point. We need the correct equipment and process to speed up this purge. What we need to know. First thing we need to know how much CO2 we need to do a purge. So we need to know the case volumes. That can be found in your OEM manual. This just happens to be a GE manual. We need to know what kind of CO2 you have on site. Is it gaseous bottled CO2 in high pressure bottles, or do you have a bulk tank? So we're looking at 800 to 1100 psi with bottles. Bulk tank, we're looking around 300 to 350 psi. Big differences in pressure that can also help how this process moves forward. So the next thing is, and Christopher talked about this a little bit earlier, is your purge procedure up to date? Have you taken the procedure and matched up with your P&ID and taken both of those documents out to the manifold to be sure that all updates have been captured and your information is up to date and it is accurate. Some of the questions I like to ask when evaluating your purge system. How long is it taking you to purge your generator? It's not unusual to hear people say that they're going a shift as much as 12 to 14 hours just to go from hydrogen to CO2 in the process. How much CO2 are you going through for each purge? If you're using gas and you don't have an automated system and a vaporizer, you're probably using 3 to 4 times the amount of CO2 that is needed to actually purge your generator. The reason for this is freezing of the bottles. You'll probably lose about the bottom third of every bottle on an 18 pack if you're using gas. So we can also get to how much we're using is by the number of bottles you're using, taking the weight of the bottle, multiplying it by 8.75 to get the standard cubic feet of CO2 that you're using for each purge. And this question is almost always a yes. Are you using more than 2 full case volumes of gas to complete a purge? You're probably not actually using more than 2, but you're using bottles with that 1/3 bottle of loss. You'll end up using 3 18 packs in a lot of situations where you can probably get it done with 1. Do you have a way to confirm the amount of CO2 that's flowed to the generator? This is very important. Having another data point where you can say, okay, I've been flowing 7,000 standard cubic feet an hour and I've flowed 3,200 standard cubic feet. I know where I'm at. Do you have a CO2 regulators that are rated for CO2 and in good function? It's not unusual to see a lot of regulators that have been there for many, many years as original equipment. So we'd like to evaluate those. Some are not in good condition. Some are even already reading the pressure of the bottles before they're hooked up to go to do the purge. So that's why we need to make sure that we have good regulators, good condition, and fully functional. What CO2 pressures and flows are you using? It is probably, most likely, most plants are running anywhere from 15, possibly up to 30 PSI of CO2 pressure, which is used to try to alleviate the freezing issues. But the issue here is that low pressure actually pushes you to be more prone to freezing. You should be somewhere in 55 to 60 PSI when you're flowing your CO2 to prevent snow or dry ice buildup in your regulators or piping. And this is a big one, as we talked about earlier, with the fleet age and less people available. Do you feel your operators have a good understanding of the processes and are well trained? We find that there's less people in plants these days. Purges are not happening as often. They're getting pushed out, sometimes 2 to 3 years between a purge. And we're not getting the experience out there like we had when we were doing outages every single year or every 6 months. So having an automated purge system will help shorten this curve and keep you using the same process every time, safely, accurately, and quickly. All right, what are our options? Over here on the left side, we have a remote automation panel. We use this panel with 3 rotary actuators, an installed explosion-proof hydrogen analyzer with a DP transmitter to know that we have flow growing across, along with your flow ball valve over here, double block and bleed valves. This type of system would be used on a newer generator setup where you have a very well-functioning manual manifold in good condition, and this is a more cost-effective way to go at automating your purge system. Now, if you have an older unit, we can look at replacing the entire manifold with a new manual manifold with ball valves and actuators rated for hydrogen, with your hydrogen pressure gauge, your CO2 pressure gauge, both with transmitters, online hydrogen monitoring system that will read all three gases. And then we can go the full route. And this actually can expand to many other things. You can add the GCMX in here for core monitoring, auxiliary panels, but this is just to jump off with online monitoring full time, an analyzer set up so that if you need to do an emergency purge, you can. It's set up in H2 and CO2. You have your DP pressure, your case pressure, your hydrogen and CO2 pressures, and all four of these gauges have transmitters as well. We actually like to put some redundant gauges in some of these systems on the case pressure for the help of confirming case pressure versus seal oil pressure to make sure we maintain those seals and we don't dump the hydrogen out the ends. What are some of the options for automating your valves? We use rotary actuators with 4 to 20 milliamp feedback or control with switches. We have solenoid valves with check valves. You can use latching solenoid valves with proximity switches, gauges, transmitters for supply gases and monitoring your case and DP, CO2 flow meters with a transmitter so we know how much gas is flowing and how much gas we have flown for the period of time during the purge. So with that, you can get 3 different points of reference on your purge to make sure you're staying accurate and meeting the needs to get us out. And of course, the installed explosion-proof analyzer. So tie-in points. So we're going to be looking at, and this would be for the remote automated panel, the RAP, or ROI. We put double block and bleeds on all of the pipes coming in, your main vent lines, your CO2 lines, your hydrogen line, as well as having a weldolet that goes out to the vent line for pushing hydrogen through the analyzer cell. So this is an overall look at what it would be if you had the ROI panel with your double block and bleeds, your existing manifold here in the center, your 2 gases for hydrogen and CO2, your fan pressure, your fan suction lines, your connection to the vent line, and your top and bottom headers. And of course, vaporizers over here in between those 2 stations. So let's talk about CO2 for a minute. Let's talk about liquid feed versus gas feed. This is a very important part of going to an automated purge system with a vaporizer because you'll need to have liquid to do that purge. Let's talk about why you're using so much CO2 with your gas bottles. This is a bottle that is used with just gas, no siphon tube. What it uses is boiled off gas from the liquid to feed your purge process. This method will end up giving you about 1/3 of a bottle loss on each bottle, approximately. It'll actually freeze to a solid block of dry ice down in this area. It'll just be a block, you can't get it out. We've seen people with hoses, heaters. It's not going to make any difference. This is frozen solid. It's not coming out there, so you're going to get a high loss, which leads to more bottles needed to do your purge. So as we go through and talk about reducing how much CO2 is needed, we're not actually talking about the amount of CO2 that's getting to the generator, but the amount of bottles that you're using where you're losing 30% of each of those bottles. Now with liquid CO2, what we're doing is we're using, when we open the valve, the boiling off the gas is forcing liquid down through the dip tube and out to a vaporizer. Both of these bottles are around 700, 800 PSI. Some I've seen at 1100, but 800 seems to be about the average across the world, I guess. Using liquid CO2 in a vaporizer, you're going to reduce your losses down to between 5 and 10% probably about this area of the bottle when we get to the bottom of the dip tube where we can't get that last bit of CO2. But we calculate when we build these as a 10% loss in every bottle so that we make sure if we design a bottle rack or set up a system for you that we do have enough bottles to complete that purge based on the case volume size. All right, now let's start talking about non-powered vaporizers. A non-powered vaporizer does not require a heater. Or the 480, 460 volts required to run that heater. We're actually taking liquid CO2, which can come from a bottle rack, a micro bulk system, or a bulk system. We're going to feed that, drop that pressure down, run it through a liquid CO2 conditioner. At this point, these pipes are frosty cold. You will see buildup. You will see frost. It is not freezing in the pipes. It's actually the ambient air dew point attaching to the pipes. As we go into the tower or accumulator, you'll see the frost right in the beginning. As it goes through, it'll start to disappear. By the time we get over here to this outlet pipe, that pipe is going to be the same temperature as the outdoor atmosphere or indoor atmosphere, wherever your system is sitting. It goes from here to our regulation rack that will feed the CO2 to the generator. It has a 4 to 20 transmitter for flow and total of the CO2 that's going through. You can see there's pressure relief valves all around this system in case we have a stop in the flow where they can blow off and not have any incidents. There's also going to be a air actuated valve that will open and close if you try to overdrive the system to more than it's capable of pushing through, or when you start to run out of CO2, to make sure that we're not burping any liquid through the system and keep your equipment safe. And here's some examples, 2 pictures left and right of an installed system in Mississippi on a smaller generator. These accumulators on average are going to be a 4x4 and a 12-foot tall unit. This one happens to be a little smaller, about 10 feet, 3x3, maybe 9 feet. But you can see that there are bottle racks with braided stainless steel hose. You have your regulator system here, which since this one was installed, we've added filtration. We found that some of these older CO2 bottles contain contaminants in there and we're clogging up our regulators. So we've added that feature to this system. Down here is your liquid conditioning regulator. It's your second stage of regulation as it goes into the vaporizer tower to get it down to that 55 PSI. We have the accumulator. From the accumulator, it's going to go to your valve rack and your process where you have your 2 different paths. You have your, actually over here is easier to see. You have your flow and totalizer. There's the air actuated valve, which is using CO2 for the actuator to make sure that you have a constant flow of gas. So it will slow down. It will actually pulse. On one of the first tests, we actually got to see this when we were overdriving the unit to push far more gas than it was capable of. And once we dialed it back in, it went back into perfect function and was delivering CO2 at a proper rate. Okay, next, we can get into the 7F automated purge system kit. This kit was put together so that we could actually adapt the existing manifold of a 7F with new components and equipment. It comes with an installation drawing package. We've also developed new software and electronics for the DHCP for remote range change from H2 and air to H2 and CO2 and air and CO2. A stainless steel marshalling box for the extra signals we're going to be looking at that have to be run back to the DCS. We're going to put in new Clark-Cooper latching solenoid valves with proximity switches for the H2 line. A Shishek explosion-proof actuator with a 1-inch ball valve and mounting hardware for your CO2. A Shishek EX actuator with a 2-inch ball valve and mounting hardware. Are my slides falling backwards? Looks like we got some notes up here. All right, let's go to the next. All right, so inside, you're going to see in the collector housing, this is the hydrogen section of the manifold. The existing are now 2 Clark-Cooper valves without proximity switches. These would be the original OEM equipment. Most of these valves have been disconnected or tie wrapped to make sure that they don't close in the event of a loss of signal from the monitoring systems that was on the automatic purge that came with these generators. They'll be replaced with new valves with open and closed proximity switches that will latch so that when we know it's closed, it's showing it's closed, and we will have no hydrogen going to the generator, which stops your scavenging and any possible feed into your generator to start the process. Down underneath that, there's that small door. You're going to see your vent line and your CO2 line. Your CO2 will add a rotary actuator, remove this, and you can see on both of these where there are tie wraps that have been put on here to make sure that these valves do not open and intermittently dump the hydrogen and start purging CO2. These will be rotary actuators with open and closed switches to use during the purge. The purge that we like to use during this process for the 7Fs is a pressure purge. So what we're going to do is we're going to trip the generator offline, get it down to speed, open up the vent valve, drop the hydrogen pressure down to about 8 to 10 psi, close the valve. We're going to then open up the CO2 valve and repressurize to 28 to 30 psi, depending on the generator and what we find works best, and do that process 2 to 3 times for the purge. This is an existing termination box that's in the collector house. We may need to add an additional box for the additional signals. This has the DC power supply for the Clark-Cooper valves for probably all 4 of these. We're going to add an additional proximity switch points for those for the Clark-Coopers in the collector house, and 2 open and closed switches for the rotary actuators on the vent and CO2 lines. And we'll need critical 120 VAC power feeds for the valves. And 4 more contacts for the valves downstairs that will show your open and closed status. And we'll look at that in just a moment. So again, we're back to this 7F automated purge screen. This whole section from here to here to here is new. This is added, it's updated. It will be programmed into your software in the Mark 6, Mark 5, whatever version you have. It's going to give you the last measured readings, which gas we're in, valve statuses, open and close, case pressure, seal oil pressure, and DP between the two, along with your normal other items that are typically monitored when the generator is running, your heat, your speed, megawatts, megavars, etc. So we've gone through all of this information, and as you can see, E1 provides a very broad spectrum of protection for your generator for efficiency and better operation. We can do analyzers, we can do hydrogen dryers, we can do condition monitoring systems, we can do new hydrogen control systems, DHCPs, We can do complete gas stations that will take care of auxiliaries of oil, seal or water systems, annunciation panels, GCMXs, and then even add to this the automation of your manifold by adding a new manifold and put the automation in there with all the software to change gases and get yourself a better and more efficient system. So the main target of this purge is we're looking to get you to an hour and 30 minutes, reducing your CO2 usage by 30 to 40%, maybe even 50% of what you've been using. And thank you all for joining us. I think we're going to jump into some questions now that Christopher and I will field. Please feel free, and we're ready to answer your questions. And thank you again. I appreciate you coming to join us today.
Yes, so thank you, Christopher and Mark, for your informative presentations. Now let's dive into our Q&A session. A quick reminder for our audience: to ask questions, simply use the questions widget. Just type them into the box located at the top right-hand corner of your screen and click submit. I can see that we have a lot of great questions coming in. So let's kick things off with this first question. It's a two-parter, so I'll try to read it slow.
Okay.
We have a case on Dofan generator with very wet hydrogen gas, and on this time already installed GGD2. We are suspicious there is oil contamination on the hydrogen. How do you increase dew point value, and can all contamination be removed by increasing Regenex mode?
Well, the Regenex mode can be extended for longer periods to try to pull that down. But if you're still seeing a very high dew point and you've been taking good care of your dryer, I would suspect there's probably some water ingression from somewhere, possibly a leak. The dryer will filter out oil on its coalescing filter. And if you are having oil contamination, another reason that your dryer might be working as well is that you have saturated the dew point with oil. And that is the first thing and the main thing that will destroy micro-sieve desiccant. As it gets saturated with oil, it can no longer absorb water. I hope that helps.
Thank you, Mark, and thank you for that interesting question. Now let's move on to another one, and this looks like a good one. How can we know if our equipment is obsolete?
If you have E1 equipment, you could send us a serial number tag. We can come out and visit the site and do an evaluation. I mean, we will come out to the site and do dew point evaluations, purity evaluations, look at your existing equipment as part of any one of these processes of adding a dryer or a purge system or overheat monitoring with a core monitor. Part of what we do as your advisor is to look over your equipment, make sure it's in good condition and it is functioning properly. So a site visit would be a great way for that to happen.
Thank you. Another great question we've gotten is just about the GCMX. So can the GCMX be combined with other equipment as a package?
Absolutely.
Field this one. Oh, go ahead, Mark.
Christopher. No, you go ahead.
So, as Mark mentioned in his presentation, especially at the end, we can do complete gas stations at Environment One. So we can take your generator condition monitor, we can put that into a gas station with purity. We can also incorporate that with information on your seal oil system, your stator water cooling. All of those things can be brought together so that you have your accessories in one area.
Fantastic. Great inquiry, and of course, a thoughtful answer from Christopher. And as we're nearing the end of our scheduled time, I'll ask this final question. What size generators can use a GCMX?
Any size.
Generator condition monitor can be used on any size hydrogen-cooled generator. We've got them installed on units as small as 15 megawatts. So definitely down to small sizes, all the way up to gigawatt-style nuclear units.
Fantastic. Well, excellent responses, Christopher and Mark. As we are near our scheduled times, we'll have to conclude our Q&A session. But please don't worry if we haven't addressed your questions, as our speakers and team will follow up with you. And that brings us to the end of our live Q&A and webinar. I'd like to express my heartfelt thanks to Christopher and Mark for their outstanding presentation, and to our sponsor E1 for making this session possible. To our attendees, keep an eye out on your email for instructions on accessing the on-demand version of this webinar, and you can also find it on our website at www.pmi-live.com. Stay connected with us for more exciting webinars. Follow us on X at BR Webinars for daily updates, and follow our LinkedIn company page, Business Review Webinars. But once again, thank you for joining us today, and I wish you all a wonderful day ahead.
Thank you.